Hello, Math 442ers. This is Professor Price. I told you all to be looking out for a video coming out your way, and this is it. I just wanted to briefly set up the next topic so that maybe we could spend a little time in the next class having y'all play with these things rather than just hearing about them for the first time. So, Chapter 5 is entitled Permutation Groups. So first off, what's a permutation? Well, I'm glad you asked. A permutation of a set, say A, is a function from A to A that is both one-to-one and onto. So in order to talk about permutations, first we kind of have to have an underlying set in mind. All right, and then one more definition to piggyback on this. A permutation group is, well, it's a group of permutations. So again, first we have to have an underlying set in mind, so of a set A. It's the set consisting of all permutations on A with the operation of function composition. All right, so for example, let's start with a fixed set A. Typically, we choose A to be the set of numbers from 1 to fill in the blank. So let's say that A is equal to the set of numbers 1, 2, 3, 4, 5. Well, then a permutation on A would be some function mapping A to itself. So maybe I'll write another copy of A below A. So then to specify a permutation from A to A, I pretty much just need some arrows stretching down here from these elements to other elements. And everything needs to go to just one thing. So maybe something like this happens. So this permutation, if I were to give it a name, say alpha, so alpha is a permutation on A, and let's see, alpha of 1 is equal to 2, alpha of 2 is equal to 3, alpha of 3 is equal to 1, alpha of 4 is equal to 5, and alpha of 5 is equal to 4. So I'm just telling you where those arrows up above are pointing. We could check that this function is one-to-one. Nothing has two different things mapped to it, and that it's onto. Everything gets hit. Okay, so now we would like to be able to represent this function in an alternate way, and the way we're going to represent this function is in what's called block form, basically the way we represent this permutation alpha in block form is we write all the elements of A, which was the set 1 through 5, and then beneath them we just want to write alpha of them. Sorry, I'm having trouble closing my alphas. So for this particular function, I think we had 1 was going to, well, I forget. I went back and looked. So 1 was going to 2, and 2 was being mapped to 3. 3 was being mapped to 1. 4 was being mapped to 5, and 5 was being mapped to 4. So this is how I would represent the permutation alpha in what I refer to as block form. The book doesn't use that terminology. Okay, so if we would like to talk about this group operation, so the group option is function composition. So let's say that alpha is our permutation that we had earlier. Supposed to be a 5 right there. It's kind of a gross one. Sorry about that. And let's make up another one, which I'll call maybe beta. All right, so that is 1 to 1 and on 2. Everything's getting hit in just once. If I want to compose alpha times beta. So in this permutation group, the set of all things that are permutations on the set A, which is the set from 1 through 5, I should be able to compose 2 group elements and get back a 3rd group element. So what would this composition look like? Well, for one thing, it's done from right to left. So if I want to know where this permutation were to take 1, well, first I would do beta of 1, and then I would feed that to alpha. So looking back, it looks like beta of 1 was 1, and that alpha of 1 was 2. So in my permutation alpha beta, I would have 1 being mapped to 2. Now what would happen to all the other elements? Well, we would need to check and see what happens to 2. It would be whatever alpha beta of 2 is, and whatever alpha beta of 3 is what we would write below 3. And so on. So now, this is not the most efficient way to do this, and I'd like to talk real quick about the most efficient way to write one of these things. So if I have a permutation that's in block form, say my original permutation alpha, I can write this in what's called cycle form. So basically I can visualize this as a collection of cycles. 1 is mapped to 2. 2 is mapped to 3. And then 3 is mapped back to 1, closing the cycle. 4 is mapped to 5, which is then in turn mapped back to 4, closing the cycle. The way that we would write a permutation in cycle form would be as follows. I would write an open parenthesis and then write where 1 is mapped after the number 1. So 1 is mapped to 2, 2 is mapped to 3, which is then mapped back to 1 and the cycle closes. And then 4 is mapped to 5, which is then mapped back to 4, and now the cycle closes. Okay, so I think I'm a little bit over 10 minutes, which is about all I wanted to do. I look forward to seeing you all in class next time. I hope you enjoyed my short video.